Hey folks, this is Mr. Word. I'm going to do a key for Geometry Do Now 19.2. That's week 19, day 2. So here we have 1A. Use this diagram, the givens and such below, as a way to prove Theorem 22. You'll need Theorem 21, the adjacent angles theorem, from the last Do Now and Exit ticket. That's simply the one that says angles that are congruent and adjacent are right angles. You'll probably also need Kappa and stuff like that. Maybe some detour theorem approaches. So here's Theorem 22. And the theorem says if 2 points are each equidistant from the endpoints of a segment, then the 2 points determine the perpendicular bisector of that segment. So let's see how this sets up those conditions. So we've got this quadrilateral here, and we've got the diagonals going here. We're supposed to prove that PQ is the perpendicular bisector to AB. And what that means is that this segment and this segment are the same length. They're congruent to each other. And these angles are right. So this segment is perpendicular to this, and it splits AB. So we know PA and PB are congruent. And we know QA and QB are congruent. That is information that's given to us. If we could prove that triangle PA whatever it is and PB whatever it is are congruent, or triangle QA whatever in the middle and BQB whatever in the middle are congruent, either one of those combinations would do a couple things. One is it would prove that these segments are congruent, so they're bisected. And it would prove that these two angles, which are adjacent to each other, are also congruent and so have to be 90 degrees each. So it would prove this here, PQ, is a perpendicular bisector for AB. It bisects it into 2 parts and it's perpendicular. So PA is congruent to PB and QA is congruent to QB. So a starting place would be to declare that PQ is congruent to itself. So after the givens, let's do that. So after givens, we can say PQ is congruent to itself. Let's say congruent to PQ by reflexive. Okay, once we've done that, we'll label that. So PQ is itself. And I'll also label the other things that are congruent. I know this is congruent to this, and this is congruent to this. And now I have side, 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 side. So I can now prove that those two triangles are congruent. I can prove that PAQ is congruent to PBQ. Okay, so let's say triangle PAQ is congruent to triangle P, find P and the low light in this room here, PBQ. Okay, by side, side, side postulate. Okay, so once we have that information, now we can start proving some angles. So we now know that this angle here and this angle here are congruent. We also know this angle here and this angle here are congruent by Kappa. So you can take one path or the other, it doesn't matter which, but either path is going to lead you to being able to prove these smaller triangles are congruent. So I'll just pick the top path. I'm going to say that angle APQ is congruent to angle PPQ by Kappa. Corresponding parts of congruent triangles are congruent. Now that I have done that, I will label that because it's always good to label things in these diagrams. So I know this is congruent to this. And why not also just mention that I could have proven that is congruent to that, since you could have gone in that route as well. Of course, now that we've proven that angle APQ and BPQ are congruent, now we can start the process of proving that AP whatever this one is and BP whatever this is are congruent. So it'd probably be useful to give that a letter. I'm just going to call it Z. Okay, so we can draw a line here. So I'm going to grab a nice bright red, and here we go. PZ. We're going to use PZ now, and PZ is going to be from P to the intersection of AB and PQ. Formally, you would have to say PQ assumed, okay. Well, I'm just going to say PQ is congruent to PQ, not PQ, PZ is congruent to PZ, okay, by reflexive, because it is itself. Note that this is an auxiliary line. I think I have too many L's in auxiliary there. Okay, so that's an auxiliary line. Now that we've got AP and BP, and we've got PZ and PZ, and we've got these two angles, APZ now and BPZ, we can prove side, angle, side. We can prove triangle APZ and BPZ are congruent. So triangle APZ is congruent to triangle BPZ. You could have used some other letter, of course, by side, angle, side postulate. Okay, now, once we've proven that, we can go on and prove that angle PZA and PZP are congruent by kappa kata. So angles, I'm going to scroll down a little bit here. Okay, so angle PZA is congruent to angle PZB by kappa kata. Corresponding parts from congruent triangles are congruent. And then with that, we now have, I'll go ahead and label those, of course. Let's see, what color do I want? I want orangish. So now I know this and this are congruent. And since they are congruent and adjacent to each other, then we can say that they are perpendicular. Okay, so now we can say angle PZA and angle PZB are right angles by the adjacent angle theorem, which says that angles that are congruent and adjacent are basically angles that are congruent and supplementary. Angles that are congruent and adjacent are going to be right angles. Okay, now that's, of course, adjacent on a straight angle. So now there's one or two more things. So we need to prove that AZ and BZ are congruent. We have to state that. So AZ is congruent. So AZ is congruent to BZ by kappa kata, of course. And then we can say, oops, I left out a C in there. Okay. And then therefore we can say that PQ is the perpendicular bisector of AB by definition of a perpendicular bisector. Okay, because it bisects AB and it does it at a right angle. Okay, now let's take a look at the next one. So 1B is going to ask you to prove Theorem 23. So Theorem 23, we have PQ, line PQ is the bisector of AB. So we've been told that information. So that means that this is a right angle and this is a right angle. It also means that we know that AQ and BQ are congruent. So So we're supposed to prove that PA and PB are congruent. Well, this one's actually going to be a whole lot easier than the last one. It's a lot less steps. So we can, if we could prove that these two triangles are congruent, then we can prove that PA and PB are congruent to each other. So let's do that. So we can prove that they are, after we say the givens, so there's the givens, then we can say, in a formal proof, by the way, you actually are supposed to write out the givens as statements, and then the reason for them is that they're given. But I'm doing a shortcut now, and I can say that PQ is congruent to PQ. Bireflexive, because it is itself. And once I've done that, I can say triangle PQA is congruent to triangle PQB by side angle side postulate. Because PQ is congruent to itself, PQA and PQB angles, those angles are congruent because they're right angles, and AQ and BQ are congruent. I might need to say that angle PQA is congruent to angle PQB by the, because right angles congruent, and that is actually theorem 1 from this book. And then we've got enough information now to say that PA and PB are congruent. So PA is congruent to PB by kappa kappa. Corresponding parts of congruent triangles are congruent. Now let's go on to this last one here. I think it's the last one. Yes, it is. So 1C. What is the reason for statement 5? You just worked with it in one of the previous questions. So that's a big giant hint that theorem 23, if a point is on the perpendicular bisector, and this is the perpendicular bisector, if a point is on it, like point P, then it is equidistant to the endpoints of the segment that is being bisected. And that is what it's saying. Sometimes that can be a little confusing to think about. We know, based on our proof, that P is equidistant to A and B, and since it is equidistant to A and B, which are the endpoints of a segment that is being bisected, then it is on the perpendicular bisector of that, that segment. And we've just done a proof for that. There are more thorough proofs that one, we'd need to be a little more rigorous than that to really formally prove it, but I think we've got a pretty good idea of it from that. Now, in this one, you're going to be working with either that theorem or you're going to be working with theorem 22. If 2 points are equidistant from the endpoints of a segment, then those 2 points determine the perpendicular bisector of that segment. So A is equidistant, A and B are equidistant to P, and they're also equidistant to Q. And so I should say P is equidistant to A and B, and Q is equidistant to B and A. And because of that, PQ determines the perpendicular bisector of that segment. PQ actually determines a line or a ray or a segment. It doesn't matter which of those you choose, but it determines the thing that will perpendicularly bisect it. So let's take a look here. So one of those is going to come into play here. So angle 1 is congruent to angle 2. Angle 3 is congruent to angle 4. And we have angle AE. We're trying to prove that AE perpendicularly bisects. So this is the line AE, which goes on forever. Doesn't just stop here. That's why it's got those arrows. Is the perpendicular bisector of BD. So to do that, we've got our given. Then we know AB is congruent to AD. So AB is congruent to AD because they are the opposite sides for angle 1 and angle 2. And then angle 3 and angle 4 congruent. And that points, of course, to CD and BC. Those are congruent because they are opposite. That's one of the isosceles triangle theorems. These are base angles of isosceles triangles. Okay. And so then we can state then that AE is a perpendicular bisector to BD. Well, what we've just proven is that A is equidistant to B and D. And C is equidistant to B and C because BC is congruent to CD and AB is congruent to AD. And so we have these 2 points which happen to be equidistant from the endpoints of a segment that we are wondering if it is going, that we're proposing is going to be perpendicularly bisected. And so we want to look at the one that talks about them being equidistant. So if a point is on the perpendicular bisector, then it is equidistant from the endpoints. That's the opposite direction. We want to use the other direction. If 2 points are each equidistant from the endpoints of a segment, the endpoints here, these 2 points being equidistant to those endpoints, then those 2 points determine a perpendicular bisector. So I would say that it is this equidistance theorem here, Theorem 22. Okay, so that would be Theorem 22 if 2 points are equidistant. My goodness, I can't type tonight. Are equidistant from the endpoints of a segment, then they determine a perpendicular bisector of that segment. And that is what the reason for statement 5 is. All right, I hope that has helped.